everyone. Thank you so much for attending our session. We kind of just want to present to you like how we're approaching blended learning at MIT for our residential courses. And so we've got Peter Pinch, Saif, Rayyan, and myself. And I'll start by just giving you a quick overview of what I do. So I'm on the educational technology team at MITx. And so we've got some resources that support all of these courses that are being run on campus for MIT students using Open edX. And so I'd like to really just call out this number, between 30 and 50 on-campus courses every semester. And so we have one full-time employee that kind of supports all of this in terms of like the actual like course author support. And so the reason that's important is because of these like 4 highlighted sorts of things that we do. And so so course provisioning is a big one. When we have 30 to 40 courses every semester running, we also have maybe like 10 more that we just provision just because, experiments that really don't end up learner-facing. And so course provisioning is a really, really big task. And so on campus, or on my team, we generally try to get that to be as short as possible of a process. So we have a few scripts that help do that. And so we have one that will actually set up the courses, and then we have another one that will actually put in some dummy content so that course authors who've never built a course before can actually kind of get started with a little bit of content. And so this is just a look at like our dashboard. We've got courses that span a whole lot of different topics. And this is a graphic I just wanted to show you. It's kind of an internal rendition of why it's so difficult for us to provision a course. So everything from a professor asking for a course to when it actually gets updated. So we really wanted to streamline that. And so to do that, we have those scripts. And also, we have a couple of different workflows that we support at the same time. And so I feel like probably the room is familiar with the studio workflow in edX. We have a slightly modified version to support our blended learning efforts a little better. We're actually in the middle of revising this right now, but that's a general overview. And then we also support XML authoring directly. And so that's editing the courses directly in the XML. And this is a quick diagram of how we support that. And so we use GitHub to manage the content. And anyway, that's just a quick overview of how we support those two things. And then we also don't upgrade every single time there's a named release. So in order to support the faculty's experiments, we try to keep consistent platforms during the semester so that they don't get interrupted by unexpected things that could come out during a release. So during the QA upgrade, we actually will test some of the features that we have put specifically on our instance of Open edX, but we also try to test the content and make sure that the courses that are currently running aren't nothing's going wrong with those. Another really big thing that we do is not only do we have instructors who are experimenting on campus with blended learning, we also have the same instructors often experimenting with MOOCs on edX.org. And so my team facilitates the content transfer between those two environments, which actually can be very tricky. This kind of goes back to the talk we just had. And so things like where the video originated can actually be kind of a problem that we have to manage with my team, and also any sort of changes in the features that are available with the named release we're currently working with and edX.org, and also just changes to the XML. As you saw before, we have course teams that are editing directly in the XML, so our source technically lives outside of the platform. So we need to stay up to date on the XML changes so that we're importing course content in whatever way we're importing it that's sound and won't break. So content transfer. And so we have a few other things. I don't want to just talk about all of the random things that we have, but if you have any other questions afterward, you can let us know. But Saif actually will go into a little detail about how he uses LaTeX to edX in the physics courses. So anyway, without further ado, Saif has some very specific examples of how we do this with physics courses.
Thank you, Shelly. Can you hear me? No. Now? What about now? Okay, great. Hi, my name is Saif Rayyan. I want to start by showing you this. The date was November 4th, 2011. There was a closed-door meeting where Anant Agrawal invited a bunch of MIT faculty. They were leaders. At that time, they're really leaders in online and blended learning, experts in educational technology, innovation, and pedagogy and teaching with computers, and education research. And his goal was, can we bring in all this innovation and all these great things that are done at MIT and make them really into a platform that enables delivering MOOCs. And what you see is the first brainstorming session. So I think this is the very first blueprint of what later became the Open edX platform. A week later, Anant hired Piotr Mitros, and 3 months later, they really came up with a new platform and offered 602X. This is my first Open edX conference, so I get to show this at least once. I've been since working on creating MOOCs and using the platform in blended learning. I'm very old school. I use GitHub to author content. I have a virtual machine running on my computer that have been customized by MITx Engineering. I use LaTeX to edX, which is open source. It's a tool that enables you to write courses in LaTeX. We use it to write a lot of problems. We do physics, and physics has a lot of equations. And it's very convenient for us to use LaTeX to author problems. This is the punch card. All my team uses the same workflow. So we use GitHub to collaborate on content. And this is basically, the circles represent the number of commits at different times of day and hour. And you can see that the only time that we really sleep is Sunday morning from 2 a.m. until 7 a.m. We've worked on creating content. We create a lot of content, and most of it is really assessment. We have hundreds of problems in each one of our courses. Now I come to introducing myself. I'm a digital learning scientist. It's something that's special to MIT because we predated Studio, we predated Open edX, we predated edX. I am a person that has the discipline knowledge, education, some background in education research. I did a postdoc in physics education research. I'm fluent in education technology and have a good understanding of the MIT culture. And the result that departments that have a person like me have been very active in driving innovations in digital learning, especially with blended learning on campus. The first instance that Peter Pinch here set up of edX was in fall 2012. That's 2 years before Open edX was announced, a year, maybe a year and a half. So we've been using the platform to do blended learning sense. If you ask an MIT professors, why do you get involved in MOOCs? The first answer that they will tell you is that because I want to improve the MIT students' learning and their experience. It's not reaching out to the world. Reaching out to the world is number two. And that kind of makes sense because if we do not understand how to use digital tools to teach our students, how are we going to teach the world? And this is our MIT specialty. So what we decided to do is to align MOOCs with our residential courses. The MOOC that we put on edX is the same course that we do on campus, and that allows us to use exactly the same content in many different ways. So since 2012, I've been running several learning experiments with various degrees of blending. And here I'm putting 3 different categories that describe some of these courses. I've done 5 or 6 different courses every single semester, different experiment. So one of the models is primary, where basically we get the MIT students, we replace the lecture, we eliminate the lecture altogether, we replace it with videos and interactive exercises, learning sequences on edX, homework is all online. We only keep 2 hours of interaction with the faculty. And that's usually very interactive time, a lot of discussion, something that's a little bit more applied. This works better for intermediate and graduate level courses. We've done several graduate level courses. You can find this video online. This is a Nobel Prize winner, Wolfgang Ketterle. He has a MOOC on atomic and optical physics, and he uses the same MOOC with his students. So he doesn't have to lecture anymore. But there's still a couple of hours that he spends with the students. And in this video, he describes his experience, and he calls it transformative. He really loved teaching in this format because he doesn't have to teach content anymore. He can now apply that content to discuss research problems. And this is really what the MIT faculty want to do with a graduate level course. Get a conversation with your students. How do you apply this knowledge to solve research problems? He loved this experience, and he basically said, I'm never going to teach in a traditional way ever again. For other classes, this model might not work. So we do what I call blended. And blended, in my opinion, is something where you blend the activities inside and outside class. So you have a lot of online content that supports the learning inside and outside class. We use this in our introductory physics because in our introductory physics we have a studio format that's already interactive. So we would love for the online tools to support the learning that happens. We do not want to eliminate the interaction. Then there is the supplementary mode where you have faculty that would like to use the content as a supplementary resource. A lot of the time it's homework and sometimes it's other learning resources. So what we really focus on in introductory classes is the immediate feedback. What we want to teach our students is how to solve physics problems. And we use the platform to teach them how to solve physics problems. So really, it's getting that feedback. Are you on the right track when you're sort of through the problem-solving process? Just keeping track of time. How many minutes there? Oh, yes. Oh, great. So this is one point that I want to make. For all our courses, whether they were MOOCs or on campus, our students spend the most time on the platform solving problems. This shows you the average time that a student spends on doing problems. For introductory physics, it's 46 hours. That's about 4 hours per week, compared to video, where it's only 4 hours for the whole semester. This is a course that doesn't have a lot of video. Quantum mechanics is a course where we eliminated the lectures and we replaced them with video sequences. Still, students spend more time doing problems than on doing video. We have about 40 hours of video, so the students spend about 28 hours playing the 40 hours of video at 1.5 speed. This is what I focus on. This is my mission in life, is to put in as much assessment content to help the students build problem-solving ability through online learning. This is how our introductory class looks like. It's a studio format. We have round tables, students working groups of 3s, tables of 9s. There are whiteboards all around the place. A lot of what we would like to see is students spending most of the time doing problems, group problem solving on the board. So this is what we love. This is what we've showed that leads to learning gains. This is what led to reducing the failure rate from 11% to 5%. My goal from blending is to support this, not eliminate it. So I'm not going to an all online, I'm going to a blended mode. We've really used the platform for all kinds of activities inside and outside class. And I'm going to mention these very quickly, but if you have any questions later, I can tell you or show you examples in person. We do a lot of online homework pre-class and after class. This turned out to be the most popular, is the online checker for written homework. And it was a very lucky accident where when we started doing this, we were afraid to move to all online. So we were like, oh, we're going to give you a tool to check your answer, but you can still submit the paper. And turned out to be basically the best thing we've ever done in terms of online learning. So what happens basically is that these are freshmen, and I'm an expert in physics. If I look at an online problem, very quickly I can decide that this is a very simple problem that I can do in my head. Or, no, this is a very complicated problem. I'm going to pull a piece of paper, I'm going to sketch a solution for that problem. Students in that level do not know how to do that. So when you give them online homework, the first thing that comes to their mind, oh, I'm smart enough, I'm going to try to do it in my head, and they completely screw it up if the problem is very difficult. By requiring students to submit the written homework, they're still accountable for the problem-solving process. And now what happened is that the online checker supports that problem-solving process by telling them, are they on the right track? Can they check for the answer? If they make mistakes, they go back to the paper and they can track it, and again, they can correct for it. Students absolutely love this. The faculty love it. We try to do as much of this as possible. We do also a lot of group submission. We do a group submission system to allow students to use edX in groups, so they can sign sign up for a group, go through a sequence on edX, and get grade for that sequence. We have online checker for growth problem solving. Just ask me about any of this after this talk, and I can show you examples. One of the best things that we offer is basically that all resources are in one place. The students absolutely love this. Because you know, this is a very common problem where you give your students 5 different websites at the beginning of the semester, and they hate it, they have no idea what to do. We basically use the open edX instance to put in everything in one place. And if we have to connect to an external site, it's going to be through the open edX. Students love this. This is a result of a survey in electricity and magnetism over 2 years, last spring and this spring. And we've been doing the same survey for years. Students absolutely love this. This is shocking. We've seen this the first time. You have to understand, I teach physics. Students hate physics. So to ask them if we want to use a tool that helps them learn, and they say yes, with 97% is just unheard of. By the way, the course evaluation at the end of the semester have not changed that much. It's averaged about 5.5 out of 7 throughout the 5 years. The thing that gets the highest rating from the students is using the checkable answers with the written homework. Almost 95% would rate it extremely helpful or very helpful. So the natural question that we ask is that the students love it, but does it actually help them learn? We've been doing research with Lori Breslaw and Jennifer DeBoer, and it turns out that it matters how you use the online check. So they've done some clustering, and they found that there are 2 kinds of sort of behavior that they can isolate. One of them leads to better performance. And it's things that you guys probably would guess. People that open the homework early, check often, take their time between checks, go one day after another trying to do problem, access more resources. It turned out that the correctness does not matter. Both clusters of students in the end somehow get to the correct answer. But how you get to the correct answer matters. And then the question next is that how can we promote such behavior? I'm not going to take all the time, so I need to let Peter, but because I'm working in this field, I have a huge wish list for things that I know would improve the Open edX platform for blended learning. I would love to talk to any of you about these things. I could just spend a whole hour talking about them, but instead I'm going to let Peter take over, and he's going to tell you about something more interesting.
I can't guarantee it'll be more interesting. Saif was talking about blended learning in the scope of a course. I'm going to talk about MicroMasters, which MIT considers a blended program. And it's blended in the sense that it starts with online courses and then leads to on-campus courses for those who choose to apply for the master's program. Anant talked about this a lot yesterday, and I won't go into too much detail other than the specific things that we're doing at MIT. Our first cohort of MicroMasters students actually took their final exam, their final comprehensive exam, on last weekend. They haven't gotten their grades yet, so I can't say how many there are yet. But we also have another MicroMasters that's in progress right now. And they're taking in-person proctored exams this week. So I'm going to show you some of the things that we've done to enhance the MicroMasters experience. Our courses are delivered on edX.org, but we wanted to transition into a blended experience for these students. So some of the things that we're trying out are a student dashboard, enhanced profiles for students, and we also had some experiments with personalized pricing so that the cost of a course is scaled to the income level of the learner. And then, as I mentioned, we have a couple different models for exams. We're doing in-person proctored exams with Pearson VUE, and we've also done a virtual proctored exam, a comprehensive exam covering the whole series. So yesterday, edX in the roadmap presentation talked about the program dashboard. That That's an in-progress work at edX, so we've been actually developing a portal site of our own that interacts with edX.org, partially because things weren't ready exactly when we wanted to, and then also because we needed to pull in some of the other data. So we have things like the Pearson exam grade coming in here, and I'm sorry if this is a little small, but it's from the website. And the basic idea here is the students have a sequence of courses. There's a status for each course, whether they're enrolled, what their current grade is, final grade. And then importantly, we've got a big widget letting them know how far they are in the program. This data that we're pulling from edX also needs to go into the admissions process so that we know what the status of the students are who may be applying for a master's program, either at MIT or with our partners. This is a couple screenshots of the enhanced profile. Unlike edX.org, we took sort of the opposite approach to user registration. It's more like applying to a master's program. We ask lots of questions. We want to know about the educational and employment background of the students, because we're considering them as potential applicants, as potential campus learners. And we also have a facility to share this information with other learners so that if you're in a program together, you can get an idea of who's in the program with you. On the left here is the learner view. If you choose to share it, this is what other learners would see of you. And then there's a modified version for the staff view that includes the current enrollments and grades so that staff who may be working with an individual learner can drill right down and get that data. We also have a search interface so that staff can search through all the learner profiles. And there's a number of faceted filters that can be applied. So you can do things like find all the students who are just about to pass the course and contact them with a note of encouragement. Or you can filter on profiles and find all your learners who are in a particular geography where there's an event happening. The current messaging feature that we have with this is a bulk email so that you can send out an email to everybody in that group. These are some of the technologies that we've been leveraging to make this happen. If anybody wants to know more about those, I'd be happy to talk about it afterwards, but these are all APIs that exist in edX.org that either the edX team or MIT contributed. The software we use for our portal is open source. It's very customized for MIT, but I'd be happy to talk about it. Going forward, we're planning more programs. I can't say how many yet, but there's a lot of them that are in development. Sometime in the next couple of weeks, we'll turn on the ability for learners to search for and send messages to other learners, so trying to build up some of the social connections amongst MicroMasters learners. And our eventual goal is actually to have some online forums as well, so that, for example, one of our programs is in supply chain management. We could put together people who are in a similar industry into a forum, and they can talk about how supply chain management affects aerospace specifically, or something like that. And then the next two are MicroMasters features that I'm hoping to work with edX on real soon. One is the ability to have electives in the program, so not everybody is taking the same set of courses. And we have to do some work on student records. With the learners who are applying to MIT programs, we have a way to transfer the student data from the MIT MicroMasters to the MIT Master's program. But we're also trying to work with other institutions to get the MicroMasters work recognized and flow into their master's programs. Sharing that student data is still work to be done. And I think that's it. Yes, thank you.
So we have time for some questions. Oh, I might need it.
Yeah, we'll have to get it back.
Questions? Anyone? No?
There we go.
Can Saif show his wish list again?
All of the presentations are being recorded and the slides will be available, but we can put the
That's
wish list
right.
up.
I'm just wondering what kind of role the forums play in the blended approach.
Sure. So there are forums in the course context. We deliver those courses on edX.org, but those forums only last as long as the course does. So we're looking for a way to have some continuity for students who are taking multiple courses. And then the additional idea is to have some ability for learners to design the membership of the forums themselves so that they can do, again, industry-based, geography-based, or content-based forums.
Hi, Anisha Bakaria from UQX here. Really great presentation, and you're doing really wonderful work. Just wondering if the student dashboard is open source for the MicroMasters.
It is open source.
Thank you.
No other promises made, though.
Other
VSD.
Hi, Peter. The student profile, is that a kind of separate app that the students have to register in when they enroll? Do you kind of get them to enroll on a separate site to say that they're in the MicroMasters as well as into
so
the courses?
we try to streamline that as much as possible, but so we have an OAuth integration so they can sign into our application using their edX credentials. Similar like how you might sign into other websites with your Facebook or your Twitter. But it's still been a bit of a hill to climb to get everyone to register and go through that process. It's helped with the students who have to schedule the in-person proctoring exams through Pearson, because the only way to do that is through our portal.
You are looking for an alternative to Responseware. Have you looked at UBCPI and other peer instruction tools actually available?
Yes, we tried to use the UBC peer instruction tool. We actually tried to use it even in class with the students. Somehow we don't get the same results as peer instruction that happens in person, because somehow getting two people to talk to each other, like there is a lot of unspoken language that sort of really is being communicated that doesn't exist online, and people tend to game the system. It does work a little bit better if you have a sequence of questions, where it gets tedious doing it in class, where you ask a question, you wait for the students to respond, and then you ask them to discuss it, and then sort of respond to it again. If you have 5 of these in a row, you could spend basically 45 minutes and not cover a lot of content. So if you put them in sequence, I would be interested to see how to improve the UBC tool and use it in somewhat an asynchronous, not as synchronous as in class.
Other questions? Wait, Randy, wait.
Just curious, how do you involve textbooks in this? Because for me, I always think of the reference material I took away from my master's programs, and so is it integrated with text? Because the online courses I've taken, I've always struggled with figuring out where it was that information was back in the course, and then when I'm leaving, if I didn't buy a text with the course, I don't have much that goes with me.
Usually our approach is that we have an open source text that is more of lecture notes that we provide for free, and we provide it in terms of as a plugin in edX where you can refer to specific pages from the content, or as a standalone PDF. We try to link to the specific pages at two different levels. At the vertical level, where here's the video and here's the content that's related to it. Sometimes at the sequential level. What's better is one of the courses that I've done with A. Pritchard. The whole course was an interactive textbook. So we did actually a study that we showed if you bring in a text and you embed assessment within the texts, 85% of the students will read 85% or more of the text. And in my opinion, that's the most effective way to actually take the online text and strip it away and integrate it within your course. But that's very challenging to do unless you start doing this from scratch.